Okay, this is your second sheet in 9.3. Some maybe more complicated story problems related to linear relations. Your first question says, you can buy work gloves from the Fix-It Store's website according to the formula C equals 5G plus 2, where C represents the cost and G represents the number of pairs of gloves you buy. So it says make a table to show the number of pairs of gloves purchased in relation to total cost. Use 5 values for G. So what I'm going to do is I'm going to put G here and C here because my values for G, I'm going to have 1 pair of gloves, 2 pairs of gloves, 3 pairs of gloves, 4, and 5 pairs of gloves. So without having to really write the formula each time, I think we could probably do this pretty quickly. If I buy 1 pair of gloves, it's going to be 5 times 1 plus 2. The cost of my order will be $7. If I buy 2 pairs of gloves, then we change this to 2, and it would be 5 times 2 plus 2, which would mean the cost is $12. 3 would be 17, 4 would be 22, and finally 5 pair would be $27. It then says graph the ordered pairs. So again, just like the questions we did in the first video, if I make this my G, or my number of gloves, number of pairs of gloves, and I was do 1, 2, 3, 4, 5. And over here, I'd label this C for the cost. Of course, it probably goes without saying, but it's dollars. Then we would have to go from 0 all the way up to 27. But what I'm going to do here is I'm going to play a little bit of a cheat game. I'm going to erase this part and start at 7. And then I'm going to go up by 5. So 7, and each of these is going to be going up by 5s. So 7, 14, oh, not 14. Oh, I did that wrong. I can't go up by 7s, can I? Let's try that again. So here I got to go up between 7 and 7 and 27. So I'm going to skip this. The first one's going to be 7, but then I have to go up by 5. So it's going to be 12, 17, 22, and 27. I'll put 27 up here. And I'll put 12, and I'll put 17, and I'll put 22. So when I graph those points, this little thing right here means I've skipped 0 through 6 and started at 7. So when I graph them, I got 1, 7, 2, 12, 3, 17, 4, 22, and 5, 27. Put my line there, and I know that it's a linear relation. Does the question C says, does the relation appear linear? I said, yes, it does, because the dots form a line on the graph. Question D, are there other points possible between the ones in the graph? So what we mean by that is, on this particular question, is that red dot that fits on the line a possibility? And I don't know, maybe. It's only possible if you were to buy 2.5 pairs of gloves. Because right here, this is 1 pair of gloves, 2 pairs of gloves, 3 pairs of gloves, 4 and 5 pairs. So that dot, that red dot I drew was actually 2.5 pairs. So maybe, I don't know, maybe you can buy just 1 mitten or 1 glove. It's possible. And if that were the case, it would cost you whatever that correlates to in the dollars. But probably not, because you can't buy half a pair of mittens or gloves. And the last question says, what might this positive 2, or the number 2, in our equation represent? So the equation was C equals 5G plus 2. And since this meant it's $5 per pair, and I would take the $5 per pair and multiply it by G, the number of gloves I bought, to figure the cost, this plus 2, since it's an internet company, probably is representing the shipping cost. So no matter how many pairs of gloves you buy, they're going to charge you $2 for shipping. Question 18 says, George is a co-operator. He has a rewards card for a hardware store he uses. He receives 40 points for every $1 he spends. He can use the points to get savings on future purchases. This is copy and complete the table showing the dollars spent in relation to the points received. So of course, it doesn't take a whole lot of brain power to figure out if he gets 40 points for every dollar spent. If he spends $2, he gets 80 points, and so on and so forth. So that's the table. How many points does George receive for spending $100? So The best thing for us to do here is to figure out what is an equation that relates to it so that we could figure out how much does he spend if he gets $100, right? So since it's 40 points for every $1 he spends, and he spends $100, we would know it's 40 multiplied by 100, right? To get that. But let's see why that's true. Because he would get 4,000 points if he spent $100. But if we look here, the difference in this column is 40. The difference in this column is 1. So if we call this one, we'll call this one cost. We'll call this one points. So if you take the cost and you multiply it by 40, that will equal your points. 40C equals points. So if he spends $100, we would substitute that for 100, and we would figure out that he has 4,000 points. And it says George can get a hammer for 100,000 points. Wow. How much money does he have to spend to get the hammer? So if we use this formula, and we said he got 100,000 points, and 40, if I divide both sides by 40, the amount of money he should have spent, or the cost of the goods he has bought, would be 100,000 divided by 40. So 100,000 divided by 40 means he would have to spend, wow, 2,500, is that right? $2,500 just to get a free hammer? Whew. That's a lot of points for a hammer. It must be a really good hammer. Very expensive. Question 19 says Shandy determined the mass of 5 pieces of a type of metal. This table shows her results. The relationship is linear, but Shandy, unfortunately, made one error in the finding of her masses. So here we have the mass went up by 11, the mass went up by 11, the mass went up by 11, the mass went up by 23. Or sorry, is that right? Yeah, 23. So that's where she made her errors. So the error was she made it here. What is the correct mass? This should be 132, not 144. And if we drew the points on her graph, and we did volume, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 1, 2, 3, 4, 5, 6, 7, 8. 8 is right here. And we'll go up, mass will be, let's go up 11, 22, 33, 44, 55, 66, 77, 88, 99, 110, 121, 132. So we'll go 8, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. There's 88 right there. So our first one's going to be there, then there, then there, then there. And it says, draw the points using Shandy's results. 144 would be somewhere like here. So instead of being linear, it's crooked linear. And instead of doing that, what they should have done is they should have corrected that. Instead of being 144, it was 132, and that would have completed our line. Question 20 says a taxi company in Edmonton charges $3 for the first 210 meters plus 20 cents for each additional meter. What is the cost of a trip of a length of 2,100 meters? Sorry, of a trip for 2,100 meters. So that would mean she would travel 10 units of distance. If we consider 1 unit of distance to be 210, then 2,100 meters of distance would be 10 units of distance. She would charge $3 for the first, $3 for the first unit, for 1 unit, and then it would be 20 cents for each of the 9 other units. So therefore, it would be $3 plus 20 cents times 9, which would be $3 plus $1.80. That means the taxi fare of 2,100 meters would be $4.80. For a length of 4.41 kilometers, so for the second one, 4.41 kilometers, well, 4.41 kilometers is equal to 4,410 meters. And what we have it is the units are divided into 210 meter units. So I want to know how many of these 210 meter units are in 410. So if I divide it by 210, I take my calculator and go that 4.410 divided by 210 equals 21. That means there are 21 units of 210 meters in that distance. So the first unit is going to cost $3. And the other 20 units are going to be 20 cents each. So it's $3 plus 20 units of 20 cents, which would be $3 plus an additional, I believe that's $4. So the cost of that second trip will be, for that will be $7 for that trip. I'm not going to graph it because that's way too complicated. Is the relationship linear? Yes, it is, because we know that it is going to be standard. Or how is it going to be linear? Because there is an equation that relates to it, and the equation, if we were to graph the ordered pairs, would be easy to determine, but it doesn't say what is the equation. It says, is it linear? So there would be a table of values, because if we were to plot these points, it would form a straight line. And is this your last question? Second last question? Use a pattern to determine, describe the pattern in each table of values, then graph them. So what we're going to do here is I'm going to put my T and my D here, and I just like working this way better. Makes it easier for me. The difference in your D is 1. The difference in your T is 1. So when I show the relationship between T and D, it's a 1 coefficient, or not necessary. When I then substitute my first ordered pairs, I realize I need a +2 to balance the two sides. So for A, I take my T value and add 2 each time to get the D value. And in the second table of values, B, I'm going to put my X and my Y here again, just because I like it better. 8 and 4, 7 and 3, 6 and 2, 2 and -2. The difference here is going down by 1. The difference here is going down by 1. And now I know my coefficient is the difference between those two, which is 1. So X does equal Y. And since 8 does not equal 4, my constant is subtracting 4. So in each of those, if I take the X value and subtract 4 from it, I get the Y. And I'm not going to graph it again because I don't have space. And your last question. Complete the table using the relationship of multiply by 2 and then add 3 to get Y. So if I take my XY, I really wish they wouldn't use horizontal tables. And I put -2, -1, 0, 1, 2, 3, and finally 11. If I multiply the X value by 2, which would be, of course, multiplying it by 2, and then add 3 to get Y, then 2 times -2 is -4, and -4 plus 3 is -1. If X is -1, then 2 times -1 is -2, and -2 plus 3 is 1. 2 times 0 is 2, plus 3 is 3, and we can kind of see the pattern here. It goes up by that. And then when we put our 2x plus 3 equals y, multiply our x by 11, and we get 22 plus 3, which is 25 equals y.